Welcome to the NPTEL online certificate course on flexible AC transmission system of fax devices. I am Dr. Abhik Bhattacharya, Assistant Professor of Electrical Engineering Department of IIT Roorkee. We shall discuss about the fax devices in detail. So, first of all, we require to discuss what is fax. Fax is a conventional AC transmission system. The ability of the transfer power is limited by the factors like thermal limit, transient stability, limit of the voltage and the short circuit current. And these limits define the maximum power, electric power, which can be effectively transmitted through the transmission line without causing any damage to the electrical equipment and the transmission line. Generally, this is achieved by the introduction of the variable impedance device like capacitor, inductor or regulating the reactive power flow in the system. For ideal transmission, the active power should be equal to the apparent power. In other words, power factor should be unity and transmission line is considered to be the lossless. Now, let us focus on the course content. Introduction to the fax. This will be a 1 hour lecture course. Followed by there will be fax concept, power flow, stability and the basic theory of line compensation, thyristor control converter based fax controller. This will be 2 hour lecture courses. Power electronics controller, we shall review the power electronics, different kind of power electronics converters and its control techniques by PWM, different kind of PWM voltage for voltage source inverters, multi-level inverter, cascade multi-level inverter and different kind of topology suitable for the fax applications will be discussed. Thereafter, we shall discuss static shunt compensator. A typical midpoint regulator will be discussed, variable impedance type and the switching converter type static verb compensator will be discussed in this course. SBC and the STATCOM and a different type, that is TCR, TCSC and its VI and the Q characteristics, VQ characteristics and the stability of the system will be discussed. Then we shall discuss about static series compensator. Concept of the static series compensation will be discussed. Voltage stability, variable impedance type series compensation by different kind of elements like GCSC, TSSC, TCSC and SSC control and its control technique, control range and its VA rating will be discussed. Thereafter, static voltage and the phase angle regulator will be discussed, its power flow control and TCVR and TCPAR. These are the two elements will be discussed thoroughly. Improvement of the transient stability by phase angle regulator will be discussed here. Thereafter, we shall discuss unified power flow controller or UPFC, the concept of the power flow control and its operations and its control, and thereafter interline power flow controller also will be discussed here. Thereafter, we shall discuss the stability of the fax devices and modeling of the fax devices, its optimizations and its placement, transient and dynamic stability enhanced by the fax devices will be covered during these hours. And thereafter, applications of the fax devices, principle of the control of the fax devices with the HVDC link and coordinated control of the fax devices with the HVDC link will be discussed. Total duration of the course will be 20 hours and now let us take the next course, that is the suggested book. The suggested book is basically Miller TJE, that is reactive power control in electric systems, and Song YH and John AT, also Hingorani and L Gyugi. These two books are of IEEE press. Thereafter, Orunabh Ghosh and Lidwich Chi by power quality enhancement using custom power devices Mathur RM and RK Verma, thyristor based fax controller for the electrical transmission system by John Willey, Padilla Care fax controller for the transmission and distributions, it is by the New Age International Private Limited. Now let us come to the point, what is fax? So let us consider that point one point here which has a power deficiency, and power will be flowed from this point to this point, and the power will be transmitted from the V1 from the node voltage which is having marked as V1 to V2 will be given by V1 into V2 by impedance of the line and the phase difference between these two lines. So, how we can enhance the power flow between these two lines? It is not necessarily the real power, also reactive power. So, both can be enhanced by the fax devices. Now, let us go back to the little history of the fax devices. There was a oil embargo in 1947 to 1979. So, due to the huge spikes in rise of the oil, then actually putting up an extra power plant became a costly. For this reason, people think of a solution where instead of putting extra power plant, power can be transmitted from the long distance one point to another. There are the environmental movement, setting up the power plant will actually have a greater, mostly based on the fossil fuel, will have a great impact on the environment. For this, the environmental movement comes into the picture, and that forces to actually shut down many of the power plant. There are the magnetic field concerned, and if you have a very high voltage transmission line, so then it will be hazardous to the inhabitant below it. For this reason, there is a magnetic field constant. Permit to build new transmission line. So, since these magnetic hazards are present, for this reason the locality from where the overhead transmission line go required to take permissions, and these permissions due to the environmental and the health related issues getting costlier day by day. And thereafter we have come into the technology, that is with the HVDC and SVCs. That gives us a scope to revisit the fax devices itself. And thereafter in 1988, in Westinghouse House started actually building up EPRI based fax devices, and parallelly GE came out with the rotary solutions, and then with the advent of the power electronics, it is highly feasible to use the fax devices nowadays. Now, let us understand the background and issues related to the fax devices, why we need transmission interconnections, pool power plant and the load centers to minimize generation cost. For example, let us take an example that for past 20 years, the load centers are in the southern part of India, and mostly we have a generation based on the fossil fuel that is closely available in the eastern part of the India. For this reason, we require to transmit either coal or the power from the eastern region to the southern region. Fax enable us basically to pool power plant and to transmit power from this actually to the load centers instead of actually putting extra power plant, and important to in a deregulated environment. An opportunity for the fax, it increases the power transfer capability of the line, and thereafter these are the few case studies. SVC it has been placed by GE in 1974, and Westinghouse House actually placed another fax devices SVC based. We shall discuss what is SVC in detail in 1975, and Siemens placed this fax devices as early as 1985 in Brazil, and TCSC, UPSC based fax devices came into the pictures in 1999. And this present tense is generations is not being built. That nowadays you can sell and purchase power like a trading market. So, for this reason there is a huge amount of economical benefit is involved using the fax devices. Now, let us understand the system architectures. So, generally transmission line have a different kind of architectures, and that is radial, interconnected and the complex network, power flow in the AC system, power flow in the parallel and the mesh paths, transmission line limitations. The steady state limitations are angular stability, thermal limits and the voltage limits. What are these? Angular stability, we of course, as we have explained in the previous slide, actually V1, the power it is transmitted, it is given by V1 into V2 by x sin delta. For this reason, there is a angular stability, the delta cannot be more than 90 degree, and there are the thermal limits, and thermal limit is basically we have estimated little bit of conservative way what is actually the worst case conditions of the thermal limit. Once actually the amount of the current flows through the transmission line increases, then it may touch the thermal limit, but it is possible to actually actively monitor the health of the line and the temperature, and thus we can also dispatch extra power dynamically controlling the temperature. There at a voltage limit, it is related to basically the insulation limit. Generally we should allow the voltage to be go around 10% higher, since it is also designed based on the worst case conditions, that mean maybe the actually when actually day of insulations is low. So, we can also considering the environmental conditions, we can increase the dynamically using the fax devices the voltage limits. There are stability issues. Stability issues are transient, all of a sudden huge change of the loads or the throwing of the any power plant will leads to the transient stability. There are dynamic stability. Dynamic stability also as an issue when load changes occurs. Thereafter voltage and subtransient reactance. Subtransient reactance is a great demerit in case of the power system. We shall discuss about the subtransient reactance with a greater details in later slide. System issues, post contingency conditions and loop flows and the short circuit levels. These are also keep in mind while designing the fax devices. Now, let us consider what is we understand by the fax devices, that is the radial parallel line. Here we can see that the power can be sent to one point to another point and by the two parallel line. But in this case generally which line will have a less impedance will carry more power. Let us consider this is a generating point A and this is the generating point B, and this having impedance x and this having impedance 2x. Then you will find that this line will carry power p by 3 and this line will carry power 2 p by 3. So, most of the power will basically go through the upper impedance line which has a lower impedance if it is a fixed impedance. But if you can control the power through this line, then you can change the different kind of situation. Let us consider the mesh kind of network and let us consider that power demand by this point C is basically 3000 megawatt, and let us assume that it can handle only 1500 megawatt of power, and generating capacity of it is 2000 megawatt. then what will happen? And bearing capacity of this point, let us mark it A, mark it B and C, and is 1000 megawatt. Then in normal cases without fax devices, then extra power of this much amount of 500 megawatt will flow through this line. So, for this reason this will be detrimental, but this can be changed by the fax devices, and these are the two kind of one is radial parallel network and the mesh network. Now, let us see that how it will be changed. Fax devices actually fax devices possesses the following attributes, and these are the advantage of it. It can provide dynamic reactive power flow. We will be discuss in detail what is it, and thereafter voltage control. We can control the voltage of the any of the bus. Generally it has been done by the shunt active power shunt compensators, and it can improve the stability of the system and control the real and reactive power simultaneously. And thus in that way we can reduce the power losses in the transmission line, because we can control the power flow of the line, improving the voltage profile and the less voltage fluctuations, since we can introduce a voltage control by the fax. Steady state and a transient stability limit will also be enhanced by the fax devices, and it provide congestions of the management of the power. We can actually take out power from the over congestion line to the less congested line by the fax devices. Security of the system can be enhanced, and chance of the blackouts will be reduced, and it provides a greater flexibility in expansion of the existing transmission line. Now, let us see that applications and the implementations. Now, when we have there are steady state issues, there are dynamics issues. So, steady state issues are the voltage limits, thermal limits, angular stability and the loop flow. So, traditional limit is basically traditional solution are the braking resistors and the load shedding. When you have a greater amount of load, you require to shed a part of the load. But you got a fixed compensations, so you cannot do much about it, and you got a line re-regulations and a better protections and increased inertia. These are the basically the solution you can think of, but with the fax devices, with the storage and the transmission link, we can increase the transient stability. We can, instead of the load shedding, we can have actively damp out the power swing curve and the post contingency voltage control. We can introduce the stability of the voltage. We can mitigate the subsynchronous resonance, and thus we can actually, as output, we can give the enhanced power transfer and the stability to the network, and this has been done by the few power element. SBC is a series element, series compensator. Statcom is actually a parallel compensator. UPSC is a combination of series and parallel combinations. Now, let us understand how does fax works for the two machine model. Now, let us consider the point A and point B, and assume that point A is a generator or has a power surplus, and point B has got power deficient. So, power will be transferred the point A to point B. Now, we can calculate what is the amount of the power it can transmit. So, for this reason we can refer to the phasor and E1 and E2, an angle between them are delta. So, real power flow, it can be rewritten as P is basically V is basically E1 into IP1. So, E1 into IPA1 can be rewritten as, so it is E2 sine delta by x into E1. Thus, value of power transmitted between the point E1 between 1 and 2 is given by E1 E2 by sine delta. Similarly, the value of the Q will be given by, it is V into IQ1. So, we can see that what is the value of IQ1, IQ1 and IQ2. IQ1 is basically, here it is E1 minus E2 cos delta by x into E1, that gives you the power. So, that values comes out to be E1's square, or you can take in the bracket E1 minus E2 cos delta by x. So, this is the active and the reactive power, and this is a phasor of particular active and reactive power. When these lines are too close and thus the delta is very less, then power can be increased by this loop by increasing the value, increasing or decreasing the value of the impedance. So, thus if we change the value of x, so we can have this lines parallelly. So, thus what happen, if you can increase the value of x or decrease the value of x, accordingly as the maximum power handling capability of the line will change. So, this is the constraint, but what will happen here, if we increase the value or increase or decrease the value of x, then accordingly it may touch the thermal limit. Since the voltage between the point A and B is same, what you are essentially doing, basically the value of the current flowing through this A and B is changing, and thus we have to consider dynamically what should be the thermal limit. Accordingly, the value of the power can be changed in this consideration. And let us consider the figure E. What happened here, it is a deregulating voltage magnitude, and it will mostly change the reactive power. So, what essentially we do, previously let us assume that I1 was the current between it, and if by injecting some amount of current, the resultant current becomes the I2, then thus the angle between, then what will happen then the reactive power element, this actually we know that reactive power is given by E1 cos E2 cos delta by x. If this value changes, then reactive power changes. So, this can be done by shunt injections. Here in this case, what happened, we inject the voltage perpendicular to the current. So, this angle is 90 degree. So, you inject the voltage perpendicular to 90 degree, and this will essentially will change the active power of the line. So, reactive power can be enhanced by inject power perpendicular to the current. And same way, injecting voltage, we can injecting voltage in series with the line. So, in this case we can inject voltage in series. In this case both E1 and E2 both will increase, and thus what will happen, effectively both P and Q both will increase and apparent power will increase. This circle is called the sphere of influence, and based on that, with a different kind of injection, different kind of objective can be achieved. Now, let us talk about general devices. So, we can talk about the shunt connected fax devices, that is shunt connected controller and to inject voltage, series connected controllers inject current, combined series series controllers, combined shunt, and that is series controller. Classification based on the power electronics devices, we will have two kind of power electronics devices. One is variable impedance type VIT, and the voltage source converter type, it is basically VSC type. We shall discuss in VSC type and all those things in subsequent classes. Now, variable impedance type controller are the following, that is static var compensation, that is used in the shunt connected system. TCSC, it is a thyristor control series compensator, it is series connected, and TCPST, thyristor control phase shifting transformer, and that is also VIT type. And also we have a voltage source converter, VCSC type controller, that is STATCOM, static synchronous compensator, it is shunt connected, it is triple SC, SSSC, that is static synchronous series compensator, it is series connected compensator, intermittent or interline power flow controller, there is combined series combinations, and UPFC is a unified power flow controller, or this is combined series shunt combinations. Now, these are the few circuit diagrams. So, that is basically, this is example of the STATCOM. So, this is basically a shunt compensation. Shunt compensation will have a two variant. One is actually it can be controlled, it can have a DC link and followed by a current controlled voltage source inverter, and it can be it can have a inductor linked, it is followed by a current source inverter. So, both can be used and both will inject the current into the system. So, these are the shunt compensation. Same way we can have a STATCOM with a battery that will actually inject the real power to the system, and it can also control the real power flow. And in a line, generally we will have a different kind of system, that is actually the SBC, we will have a TCSR, there are TCSC, thereafter we will for mitigate the harmonics we will have a filters, thereafter we may have inductors to improve the power factor, capacitor improve the power factor, and thereafter it is TCBR, it is essentially control the power flow between these two lines. So, now let us see that different series connected controller. This is essentially SSC. So, and so it can inject voltage in phase or quadrature, and thereafter it is SSC with the storage, it can also inject the voltage in phase. So, thus it has advantage, one it can mitigate the sag and it can enhance the power flow in the line, and in SSC with the storage it can actually inject as well as absorb sag and soil, both the conditions. And another is TCSC, essentially these are the, this is basically injects the voltage in series, this controls the impedance of the system. So, what does it do? You know, this TCSC is essentially control the impedance of the line, and line accordingly will be changed by the firing angle of the system. And thereafter we have a D, that is TCSC here, it is all the same. So, this will be a dynamic inductor will be placed into the system to reduce the power handling capability of the line. It is generally a diminisher, and this is generally a enhancer of the power handling capability of the line. Next, it is basic fax controller of the single line diagram we can show, that is basically a controller called TPSTC or TCPR. So, it has both series and shunt controller. It can control both series and shunt, and thus it can control voltage and current together. Same way, another version is by the voltage source inverter or the STATCOM and the SSC that forms UPFC. It is more versatile devices and it can have features like power flow control, harmonic mitigation. If it can mitigate the harmonic, then it is said to be the power quality conditioner. That is all for the today's lectures. Thank you.